I am Kimberly and Calaque, and today we're going to talk about homogeneous and heterogeneous mixture. So first, let us define what is mixture. So a mixture is two or more substances combined. For example, salt plus water are the compositions of seawater. Whoa! So, for example, powdered milk plus water. Chocolate chips added on the cookies. So, that produces chocolate chips cookies. That's right. Those are examples of mixtures. Mixtures either form homogeneous or heterogeneous mixtures. Now, let's go further. As I've said, mixture can either form homogeneous or heterogeneous. So, let us first define what is heterogeneous mixture. So, a heterogeneous mixture comes from the word hetero, which means different. So, heterogeneous mixture is a non-uniform mixture. Its appearance is not the same. The substances present in the mixture can be easily identified. When we say heterogeneous mixture, it has two or more phases and a non-uniform composition. Particles in heterogeneous mixture are not evenly distributed. For example, this cookie. You can easily determine which is the chocolate chip and which is the cookie, right? Another example of heterogeneous mixture is oil and water. You can easily recognize the oil layer above the water. That's why it is heterogeneous mixture. So now, let's move on to homogeneous mixture. Homogeneous comes from the word homo, which means the same. So, a homogeneous mixture is a mixture which has the same or uniform composition. So, a homogeneous mixture, it has two or more components, but they're evenly mixed, so they appear to be a one thing. A homogeneous could be a mixture of an element or compound. One example of a homogeneous mixture is alcohol. It has uniform composition throughout its mass. Another example of a homogeneous mixture is when you mix milk and water. When you're mixing it, they're becoming one. So now, let's differentiate homogeneous to heterogeneous mixture. So homogeneous mixture, it has uniform composition throughout its mass, while the heterogeneous mixture, it has non-uniform composition throughout its mass. In homogeneous mixture, it has no visible boundary of separation, while in heterogeneous mixture, it has visible boundary of separation. In homogeneous, all homogeneous mixture is called solution, while all suspension and colloid is called heterogeneous mixture. And now, we are done with the mixtures. Let's now separate them. So, there are ways to separate mixtures. Components of mixtures can be separated into different parts by physical means. So, one way to separate a mixture is by sifting. Sifting involves a sieve or a sifter to separate solids that have varying sizes. For examples, rocks, grave, or sand. So another one is for magnetic attraction. Magnetic attraction, which is a separation of magnetic material from non-magnetic material. Magnetic material includes iron, steel, nickel, or cobalt. Example of this is separating iron filling from sand. Evaporation can be used to separate mixtures as well. It involves heating the solution until the liquid turns to gases and leave the solids behind. For example, boiling a solution of water and salt until all that are left is salt crystals. So another way of separating mixtures is by filtration. Filtration removes solids from liquids by using a filter. For example, separating noodles from water using filtration. So when you're cooking a pancit canton or spaghetti, and it is done, you can use a filtration device to separate the water from the noodles. What are the ways of separating mixtures again? So the first one is by sifting, the second one is by magnetic attraction, the third one is by evaporation, and the fourth one is by, yes, that's right, that's for filtration. So that's all for today. I hope you learned something. Thank you for listening. Goodbye and see you around!